In number 16, we're given the radius of a circle is decreasing at a constant rate of 1 centimeter per second. So we're being told that dr dt is equal to negative 1/10 or negative 0.1. And in terms of the circumference, what is the rate of change of the area of the circle in square centimeters per second? Okay, so we have a circle, which is a equals pi r squared. Right? And we know that dA dt is equal to pi times the derivative of r squared, which is 2r dr dt. Now what the question writers are looking for here is for you to convert this over to circumference. We know that circumference is pi times the diameter, and the diameter is twice the radius. So another way of saying the circumference is 2 pi r, which is exactly what we have right here. So dA dt is actually the circumference times dr dt. But we're told that dr dt is negative 1/10. So our area is negative 1/10 times the circumference, which happens to be b. With number 17, the base b of a triangle is increasing at 3 inches per minute, while the height is decreasing at a rate of 3 inches per minute. All right, so the base is increasing, which means dB dt is equal to 3. The height is decreasing, so dH dt is equal to negative 3. Which of the following must be true about the area of the triangle? We see area increasing, area decreasing, or area remains the same. So we're interested in how is the area changing, which means we want dA dt. Well, let's start with just A. A is equal to half the base times the height. So dA dt, that's going to be equal to 1/2. Will stay, that's our coefficient. And now we have a product rule. Right? We can derive the first, keep the second, derive the second, keep the first, so on and so forth. So we're going to have, we'll keep the b, and we'll derive the h. Oops, sorry, dH dt, I'm getting ahead of myself. Plus, now we keep the h and derive the b. So we have b dH dt plus h dB dt. All right, but dB dt is 3. Right, so 1/2. And then dH dt is negative 3. So we have negative 3b plus 3h. And that's dA dt. Okay, so now we have to turn this into one of our answers. Okay. Well, A says that the area is always increasing. Is this true that this derivative right here will always be positive? Seems to be not the case because, for example, if B is 2 units and H is 1 unit, all right, which perhaps is the possibility because we're not told anything about the sides, but if B is 2 and H is 1, then we would end up having negative 6 plus 3, which is a negative number, and therefore dA dt is negative, which means the area is decreasing. So A is out. But since we just found this out, does that mean that A is always decreasing? Well, what if we flip it? What if the base is 1 and the height's 2? Well, then now we're going to have negative 3 plus 6, which is a positive. So A cannot always be decreasing. We also know that A is not going to remain constant because we just talked about how it changed. So we know that A is decreasing when one of these two things is happening. All right. Well, A is decreasing when this term right here is negative. Right? So this term right here will be negative. We got negative 3b plus 3h. We're interested, when is this term negative? This term is going to be negative when b is larger than h. Okay, because if b is larger than h, when we multiply b times negative 3, it'll produce something larger than when we multiply the positive h number by 3. So when b is larger than h, this is decreasing, or rather it's negative, which means the area is decreasing. So b larger than h, we see it right there. So our answer is D. And finally, with number 18, we see that The function f is continuous on the closed interval from 0 to 2, and some values are given in the table above. The equation, put that back there, the equation f of x is equal to a half must have at least 2 solutions in the interval if k is equal to what number? Alright, so we are talking about the intermediate value theorem here. Let's make a quick plot of the points. Okay, over 0 up 1. Alright, that's 1 unit up. Over 1 up k, we don't know anything about that yet, but over 2 and up 2. So here's 1, here's 2, there's 2 right there, over 2 up 2. Okay, in addition to that, we're told that the function, or the equation f of x equals a half must have 2 solutions if k is equal to what number? Alright, so in other words, here is a half right down there, that line. Alright, that's the y equals 1/2 line. In order for there to be 2 solutions, that means we have to cross our function, which I'm going to draw in red, has to cross the black line twice. We cannot just go right straight from one point to the other. We need to get below this value, and we need to get back above the value. Right. Well, this value right here is a half, so we have to get below a half and then back up above a half. The only way we can do that is if we have a value at 1 which is less than a half. And the only one of these 5 choices, which is less than a half, is 0. Right. If k is any one of these other 4 choices, we could still have 2 solutions, but we might not. And this says we must have. And the only way we must have is if we definitely drop below, and the only way we definitely drop below is if the function's value at 1 is 0.